Hello, my name is Mutembei Kariuki, and welcome to AI Expo Africa 2020. I am part of a startup called Fastagger. I am at Fastagger as the CEO and co-founder. What we are is a startup that is democratizing AI, building solutions to some of the toughest challenges on the African continent, as well as creating jobs. How we do this is we are connecting the millions of unemployed young people on the continent to the vast market of data labeling. And as we are engaging them, we are building data sets for machine learning and AI problems on the continent so that they can be used as, ground truth data for these challenges. A little bit about Fastagger is that we as a team have just over 30 years of combined experience in operations, machine learning, software development, and social impact. My co-founder and COO, Stephanie, has a master's in big data analytics and machine learning from Spain. My CTO, Jude Mwenda, has been working for the World Bank as well as the Harvard Geography Department in the space of GIS, and is currently doing his PhD at Georgia Tech. Focusing on environmental sensing using machine learning. I myself have worked in different geographies and social impact. So we bring quite an extensive experience of looking at how you can use a data-centric and data approach towards solving different challenges. So I'm going to start with the whole idea of like why we are having this particular discussion today is the whole concept of using AI for good. How can you take mapping and satellite imagery and a lot of other Earth observation data to solve a critical challenge, which is having sustainable agriculture on the continent? I'm going to give a quote by Dr. Youssef Tavelli of the Next Einstein Foundation and what he says about the challenge that we are facing in agriculture on the continent. I quote, "In a world increasingly prone to the natural disasters resulting from climate change, if Africa does not devise methods to adapt its agricultural processes to climate change, it will likely face a 22% yield loss by 2050, further accentuated by the existing food security crisis on the continent." The AU also estimates that hunger costs African countries between 1.9% and 16.5% of their GDPs. One sector that demonstrates the immense potential for AI adaptability in Africa is the agricultural sector. And this is the premise that we're starting this particular conversation on. How can we use mapping data in AI for good for agriculture on the African continent? Take a look at this picture. What do you see? This is an example of the crop failure that is happening on the continent. One, because of climate change, and two, because of agricultural practices that are not sustainable. And we are not able to predict the different weather patterns and the different emergencies that are going to be faced because of climate change. This is what we don't want to happen across the continent, but it's already starting to happen. The climate patterns are changing, yet if we were able to predict what's going to happen, we could come up with a lot of mitigating measures to help the farmers avoid the losses and avoid food security challenges in the different African countries. What we do want is this image. We want bountiful harvests in the different farms across the continent. Something to note is by 2050, there'll be 2.1 billion Africans on the African continent. If we don't get it right in terms of agriculture, the food security challenge is going to be much, much larger than it is today. This next picture is the ideal of how agriculture should be on the African continent by 2050. We need to use technology, mapping data, IoT, cloud computing to solve the challenges and increase the yield and of the land on the African continent. We need the young people such as this gentleman learning how to use technologies to improve agriculture on the African continent. And this is what this whole conversation today is going to be about. How do we use Earth observation data and other technologies in mapping as AI for good in the agriculture sector? Let's take another look at the global population. So currently there are about 7.9 billion people on the planet. About 1.4 billion of these are farmers. And all the 7.9 billion need to eat. Africa has about 60% of the world's arable land, but the lowest yield per acre. Kenya, for example, has 8 million smallholder farmers. The agricultural sector accounts for 34.25% of the GDP in Kenya. That's slightly above a third of the GDP, and it supports many sectors, such as the hospitality sector, in terms of restaurants and hotels across the country. Now, this is how important agriculture is to an economy. And the fact that 60% of the arable land on the planet is in Africa, that means the population that is to come needs to be fed using the land in Africa. Digital agriculture is the way forward. It empowers farmers. You can see in this image that it is in every part of the ecosystem. Whether you're talking about irrigation, whether you're talking about fertilizers, whether you're talking about harvesting, whether you're talking about livestock, whether you're talking about genomics, whether you're talking about the processing of food, digital farming is the way to go, and satellite imagery is key in this. Digital agriculture can be defined as the information and communication technologies and data ecosystems to support the development and delivery of timely, targeted, that means localized, information and services to make farming profitable and sustainable. That's socially, economically, and environmentally, while delivering safe, nutritious, and affordable food for all. All this is connected to the emerging technologies on the planet. That's cloud computing, encompasses all this and enabling every individual to access the data. Whether you're talking about IoT to do the soil monitoring and the nutrient sensing, or you're talking about the geographical information systems, or the unmanned aerial vehicles, or the satellite images that are going to be used to augment this data. All of them come together with the Industry 4.0 technologies. I'll give you a bit of an overview about the different spaces where AI in agriculture is impacting the field. Seed and animal breeding. This is in selection. AI can predict which combination of genes contribute a beneficial trait to a plant or animal, and we can replicate this and use it to enhance the yield. Soil and animal fertility. This is an assessment. AI can provide an accurate assessment of the best conditions based on chemical analysis at a fraction of the cost. Plant and animal protection. This is in treatments. AI can identify and predict diseases and pests and the best modes of removal or treatment. Plant and animal feeding, irrigation and fertilizer application. AI can predict the optimal mix of agronomic products, irrigation patterns, and nutrients application time. Harvesting, to ensure timely and efficiently harvest processes. AI can help digitize harvesting, and we have companies such as Hello Tractor and the Internet of Things which are doing this. And also, finally, market distribution. AI can help predict efficient logistics to market products straight from the farm to the consumer. And then an example of this is 7-Eleven stores in Japan. And now we move into the crux of this particular talk. What are some of the challenges in using AI in agriculture? One of the biggest challenges is you'll find that AI project managers or AI engineers or data scientists such as Alice, one of the biggest challenges is the lack of capacity to label large amounts of training data required to build this AI. And if we're talking about satellite imagery, most of it is not labeled appropriately over the African continent. And this is where the big challenge comes in, and this is where Fastagger comes in. Because number one, we're a data labeling company, and one of the first things that we're focusing on is creating these labeled data sets for the African continent. An example is to label 100,000 images, which are needed to make the algorithms required to develop AI, you'd need about 10,000 man hours to label this. And that's a long time for any small team to do. And this is one of the solutions that we are providing. An example is this. A satellite image is usually broken down to about 100 tasks, and each one of these has multiple objects which need to be labeled. Let's say a trained person takes about 20 seconds per label. This could take about 10 hours for one satellite image, and you usually need to take a lot more images so that you can be able to train a model to the right precision. So what we have is we've built a platform, and there are many other platforms where you can upload this imagery and have it labeled appropriately, and you can use it to develop your algorithms. Now, I come to the use cases of how do you use mapping for good in the sense of AI for agriculture. One of the key use cases is farm boundary identification. This particular example is from a paper by Waldner in 2020. It's entitled Deep Learning on Edge, Extracting Field Boundaries from Satellite Imagery with a Convolutional Neural Network. This is remote sensing on environment. Automatic extraction of field boundaries from satellite imagery would reduce the reliance on field agents and manual input of land parcel records, which is time consuming. By using the satellite imagery and applying machine learning and deep learning, this would create new remote products and services, such as a correct delineation of agricultural parcels for applications such as estimation of agricultural subsidies. A lot of challenges come into trying to decide, to find out how big are the smallholder farmers' parcels of land or different farmers' parcels of land, so that you can be able to allocate for them subsidies so that you can reduce the impact of climate change or enable them to acquire fertilizers to improve their yield. This satellite imagery and machine learning can be used for this use case. Second is this can be used to provide digital records for farmers by understanding the field boundaries so that you can ensure advisory services are delivered to these farmers and insurance products are delivered to these farmers. And this is one of the key use cases within using mapping data and AI for agriculture. Another use case is yield estimation. Here you can see a paper by Kayad in 2019, monitoring within field variability of corn yields using Sentinel-2 and machine learning techniques. This you can see is different time periods on the same plot of land and seeing the yield in terms of tons per hectare. Being able to predict this is essential to enable countries to map out, the challenges, whether it's about grain reserves, whether it's about droughts coming into the country, whether it's about supporting farmers, right? What we're doing here is we're using satellite imagery and we're using vegetation indices such as the normal distribution of vegetation index on satellite images from Sentinel-2, from the Copernicus Open Access Hub, and applying machine learning algorithms that are trained to pick out the different crops and be able to predict the yield. This is extremely important because we know, especially in Africa, a lot of the inflation is connected to food prices. And if you can be able to correctly predict and mitigate the effects of a famine or low yields production in a country and find out the reasons why the yield is less, then you can be able to really safeguard the economies of African countries. So this is another key example of how to use mapping for good in agriculture. Finally, forage availability and depletion predictions. One of the key challenges that are happening on the African continent is we have agricultural communities in the different countries as well as pastoralist communities. And as climate change is coming, what we're finding is a lot of these communities are clashing because the pastoralist communities are lacking forage land for their livestock. And what you end up having is conflicts. And in countries such as Kenya, you found that a lot of communities fight and there are actually deaths reported from these fights. And this is expected to increase. So in terms of using satellite imagery to track the forage and the depletion of this forage, across the continent in the different countries and apply machine learning to these satellite images in order to predict where the forage is available and where it's being depleted and what can be done to mitigate these effects. That is extremely important in ensuring that one, conflict does not happen, and two, we have sustainable livestock farming on the continent, because most of the continent is still full of individuals who are doing pastoralist farming. This is extremely important in how you can use mapping for good and use AI to solve such a critical issue. Finally, I'll share a bit about what kind of partnerships Fastagger has been having in ensuring our ability to work on this data. We have recently finished an 3-month accelerator with Airbus, where we got a lot of the technical expertise to work on this satellite data and also access this data. We've been working with Liquid Telecom to upskill the labelers who are working on our platforms. And we've also been working with the IMAGERY platform, which was set up in 2016 by the government of Kenya through the Ministry of Information, Communication and Technology, and is currently being managed by the Kenya Private Sector Association. And they are the ones who have, on this digital platform, a lot of young people who have been trained with digital skills and can do this labeling. And so we've already started working with about 70 of these young people. So as you can see, what we are doing is we are connecting young people to new opportunities, and we are creating AI that is going to solve challenges, connecting what is happening in academia to actual solutions that are going to support the continent. So thank you. And I'm happy to answer any of the questions you may have. I'll be in the speaker lounge. You can come in and ask me any questions and we can have a conversation. You can also send me an email on my email address, which is here on the screen, as well as visit us on our website and reach out to us there. So thank you very much. And I look forward to engaging with you as we experience the AI Expo Africa 2020. Thank you.